Okay, so in this video, I want to go through um, some of the protein recommendations and kind of summing up a lot of what we've talked about in class as far as the amino acid pool and its role and how amino acids are utilized in the body. Well, what we've learned there obviously is going to affect what we would recommend in regards to protein intake. So let's start very general, then we'll get a little more specific. So, generally, the rule of thumb, and you see this in most nutrition circles, is that for the normal individual to consume roughly zero point 0.8 to 1 gram of protein per kilogram of body weight per day. Now, that's not getting into the type of protein, complete, incomplete. That doesn't get into what's the role of exercise. We're going to get to those in a second. But that's a general recommendation, and even in individuals who are exercising that have a need to, whether it's increase muscle mass or at least prevent muscle from being used for energy, like in aerobic athletes, endurance athletes, we still don't see the recommendations get incredibly high. With carbohydrate intake, we would see that easily double sometimes in athletes. Oh, we don't see that here with proteins. At most we're seeing, 1.2, 1.4, 1.6 grams per kilogram body weight. To tell you, there's very good evidence now, and the consensus really in this area is that once you get above 1.6 grams per kilogram body weight, even in strength athletes, there just is very little improvement in muscle hypertrophy, muscle growth with the more protein you take. And it makes sense given what we've discussed as far as the amino acid pool. Okay, so that's kind of the basic recommendations. So let's dig into these a little bit more. If you start to think about this as percent of your diet, this is in the ballpark of 10, 15, maybe 20% of your diet. And again, we're talking about a normal diet. We're not getting into keto diets or things like that, which we'll talk about in a few classes. That may alter some of this. We're just talking a normal, regular diet that we would see for most individuals. And so that's kind of the relative. Obviously, this is far less than what we see with carbohydrate intake, because of amino acid pool, the need to really increase protein intake as a sizable part of your diet, there's just not good evidence that it really is more beneficial. Now, so let's talk about some special circumstances, right? And one, which should be obvious, is what about the sources of these? What about someone who is taking more of a plant-based, vegan, whatever term you want to use, diet, where a lot of their amino acids are, they're not getting these indispensable amino acids, a lot of incomplete protein? Well, that's a good question, and we've talked about in class how important those are, and so getting a balanced mix of these amino acids is very key. So in those individuals, yeah, we want to make sure we are getting a wide variety of these high protein sources, particularly legumes. Legumes are peas, beans, other vegetables with a pod. Some more fibrous vegetables, things like tofu, which I know not everyone likes. Nuts. Nuts are a good option. Walnuts, hazelnuts, things like that. Where we're getting a wide variety of amino acid profiles to alleviate any concerns as far as not getting certain indispensable amino acids. So outside of that, increasing the volume of protein is probably less important. Um, Not as important as getting these wide-ranging sources. There are some other factors to take in mind here, and we hinted on this when we talked about the amino acid pool, because clearly we can see a time where if momentarily the amino acid pool is diminished, say after exercise. So you've had an exercise session, 45 minutes, very strenuous, you've used a lot of energy, and you've broken down proteins in the muscle and other parts of the body. Well, there's good evidence that that would be a time, an intermittent time, where the amino acid pool would be diminished. And so replacing those amino acids quickly during that time would be more beneficial than doing it 3-4 hours later. There's good evidence of that, I think. And so there's good evidence that the timing of this intake, we call it an anabolic window, where we can make sure we're getting ample amino acids in that time can really help to stabilize an amino acid pool. There's also good evidence that taking carbohydrate at the same time increases insulin secretion, which improves utilization of those amino acids, digestion of them, absorption of those. And so there's good evidence doing that post-workout, post-session, whatever you're doing, is very helpful. And even things we can do to improve the rate of absorption. There's good evidence that consuming a fluid or a beverage which will assist with that, particularly if those have amino acids in them. And this is where we might get into different formulations that are out there post-workout. There's some people who use chocolate milk and things like that, and there's evidence those things might be quite helpful in regards to the timing of it. We also have situations where, what about individuals who are consuming too much or maybe too little protein, right? And too much, I'm saying too much, I don't mean like, one day you ate an entire chicken, and which is a lot, and then, I'm going to die. No, we're talking long-term, chronically taking in 3.5 grams per kilogram body weight, substantially higher above what's recommended. Well, in the short term, there's not good evidence this causes any issues, at least not in humans. Aside from increased caloric intake that may go with that, we likely do a pretty good job of keeping the amino acid pool steady in that regards. It's more the long-term consideration, and I will tell you the evidence here is a little mixed because it's hard to research. It's hard to do research studies on human subjects for 10 years, having them take in excess amounts of protein. There's not good ways to look at that. And so a lot of this research is animal research. It's even more anecdotal research. But there's at least some evidence that we're going to see some impairment on renal function. This may affect things like calcium excretion, maybe even long-term play a role in decreased renal function. And again, the evidence is mixed there, but I think at least theoretically that is possible. Let's look on the other side. What about energy restriction? And this could be because of someone dieting, right? This could be an individual who may have anorexia nervosa or some other disordered eating pattern. This may be, as much as we hate to talk about this, parts of the world where famine, civil unrest causes mass effects on food supply for months, years at a time. And so in these individuals, again, it's kind of similar to what we saw before. Short term, we don't see a lot of effect on this, so we will see loss of skeletal muscle function, obviously. Dehydration becomes a big issue in these individuals, even more so than protein loss. But we will see in negative nitrogen balance, we'll start to see decreases in skeletal muscle size, skeletal muscle function. The bigger issue becomes long-term. And this is where we start to see chronic effects not just on skeletal muscle, but on the immune system, on other cell types, where the decrease of protein is going to play a role in numerous other cells and their function. We'll even see effects on various different hormones. Again, anything that proteins do in the body, any of the functions they play, which we've talked about previously, we're going to see those things impaired. And so, not surprisingly, we're seeing a long-term deficit in protein, and typically a caloric deficit, a sizable one with that as well. That gets really concerning from a health perspective, from a medical perspective. And so something we want to be concerned about. And nutritionally, unfortunately, in so many parts of the world where there are issues in regards to consistent food sources or reliable food sources, this can be a very, very important issue. Okay, a good place to pause here as far as talking about some of the recommendations for protein, and we'll see you in the next video.